Welcome, everybody, to the American Space Museum. I'm Mark Marquette, and we're so glad you're with us to stay curious today with Mr. Mikey Haddad. Welcome.
Thank you. Good to be here, Mark.
Haddad is how you pronounce your name. Haddad, right?
Yes, sir.
Well, we're glad to have you on Stay Curious here today. Mikey Haddad had over a 30-year career at NASA, focusing on payloads. He is what I call the quintessential NASA space shuttle worker, being involved on the hands-on level as a senior systems engineer, servicing payloads of America's great fleet of reusable spaceships. And welcome. We appreciate your friendship here at the museum. Tell us a little bit about how you found Stay Curious.
Basically, I got a message from Mike Leinbach, who who is the launch director and, of course, wrote the book Bringing Columbia Home, that he had contacted y'all and says, hey, that this may be something that may be good, is to talk payloads, knowing we came from the payload. Again, he was my boss for Space Station. And so when that happened, I got in touch with you. And
yes.
Here we are.
So we thank Mike Leinbach, who launched 30-some shuttles. And if I got my shuttle scroll here, I can tell you exactly. Fetch the scroll. Yeah, Mike launched 37, I believe, of those space shuttle missions. And he's going to be one of the speakers at our shuttle Fest, celebrating the 50th anniversary of the shuttle being okayed by the U.S. Congress right there. Unfortunately, you're going to be out of town for this, but we want everybody to know we're going to broadcast this live on Facebook, YouTube, Twitch, and Spotify, just like we do Stay Curious at 4 o'clock Eastern Daylight Time weekdays. Free admission. We've got astronaut Mike McCulley and Winston Scott there. I think there's going to be an astronaut or two make a guest appearance. And, of course, space workers like you, Mikey, is what it's all about, talking about this fabulous space shuttle that the legacy lives today in the International Space Station going overhead. Mm-hmm. And when you think about that, 250 miles above us here are 7 astronauts working on labs and engineering things and so forth. You had a piece of that. And how do you feel about that?
It's awesome. Like last night, especially, I went outside and it flew over Cocoa Beach last night.
It was overhead.
It was overhead. And so, knowing that I had a piece of making that happen, it's just every time I see it fly overhead, it's just amazing.
There's
well,
for that.
Well, we welcome Mikey's friendship and support of ASM, and we're thrilled to have you as a frequent guest on Stay Curious to talk about the science and manufacturing done on the space shuttle. And, you own a piece of that space shuttle along with like 5,000 of your closest friends, in there. So,
if Mark would move the mic that way.
So,
sure.
Yeah, well,
Sorry,
we've got Trekkie Techies in the house today. Jessica Galloway, thank you. Marty Winkle, my co-producer for 2 years and over 500 episodes, had a personal thing going on today, so it worked out that Jessica come in here. And she helps us most times remotely. Okay. And she was so integral in July to taking us up to this level, Mike, where we're looking at like a TV newscast every day. So
I was trying to go to a Star Trek convention today.
Yeah, she's going to a Star Trek convention in Chicago today. And are all the biggies going to be there?
Yeah, all the biggies.
All the biggies.
Shat's
going to be there, huh?
And
Uhuru?
No, Uhuru's not going to be there. It's Shatner and Chekhov, one of the movie characters, Savick, Robin Curtis.
Oh, yeah. Okay.
So it's just a lot of those, a lot of the new Trek, a lot of the movies. I'm super hyped. So
well,
excellent.
Follow us for pictures.
That's her wheelhouse there.
I'll have to tag the Space Museum, a little shameless self-promotion.
There you go. We also, to give a little promotion there, we wanted to thank the Hyatt Place. You're coming from the Hyatt Place studios inside the American Space Museum. Mikey, we're just 11 miles, according to Google Maps, from Pad 39B over there where that Artemis rocket is probably getting rained on a little bit this afternoon. I wanted to get over there and take a picture of the SLS and Falcon 9 on the pad over there. I see a lot of good pictures of that last couple of days, but there's an 11-17 launch of 4 commercial crew men going to the space station. Mm-hmm. You've been involved in this whole thing for 30-some years. Give us a quick take, Mikey, of the commercial crew situation taking over the Cape. And
it's kind of, I think it's kind of neat. You figure that would be the next step. There's easy access to to low Earth orbit. It's almost like, where Delta Airlines, you had planes that would fly to Arizona or then eventually to Australia. Why not do the same now with rockets?
Yeah.
Where if people want to go to low Earth orbit, let the commercial people take it over, and then of course NASA focuses on kind of the outreach stuff. So I think it's kind of neat. I'm glad it's happening. To tell you the truth, it's a different world.
Yeah, it is. Then when you were out there for over 30 years, you got an illustrious background there. Tell us a little bit about where you grew up and how you got in this space business.
Okay. Well, actually, I was born in Cleveland, Ohio. Go Browns! And moved
Browns.
Down, yeah, moved down when I was just 9 years old. Our folks moved down, but I was a space nut back then in Ohio, and we were going to move to Florida.
Sure notes, yeah.
And my dad said, we're moving to this city called Titusville. I go, Titusville, where's that at? He goes, I'm not sure. Look it up on the map. Well, I look it up on the map, and it's right across the water from Kennedy Space Center. And I thought I died and gone to heaven. I says, I'm going to where they launched the rockets, and that was it. And ever since then, it's been in my blood and still is today.
Good,
Sure.
good. Well, you wrote a book about payloads. We're going to talk about that. And like I said, Mikey Haddad is going to be a great guest here at the American Space Museum. We're going to incorporate him into a monthly show, just like we had Mr. Hugh Harris, the voice of NASA, on yesterday to talk about the shuttles. And that's pretty cool.
Yeah.
89-year-old Hugh Harris. And he enjoys being involved with Stay Curious.
Okay.
And he certainly adds a lot to it. If y'all didn't see that program, we have all of our programs since July are on YouTube, and then he can go to Facebook and see all of the episodes there. We're up to episode 537 today that we've done Monday through Friday, born out of the pandemic. Now, I want to tell you're a grown man, but we're calling you Mikey, and you like that. And tell us how you got that nickname.
Well, actually, the office we had at times had 3 and 4 Michaels in it. Michaels. And
You
so,
have to.
so yeah, basically there was a Mike, there's a Michael, and they just said, well, let's call you Mikey. And it kind of stuck. And so even today, even my nieces and nephews and them still call me Mikey, Uncle Mikey, yep. Yeah.
Well, there's been a cute commercial about give it to Mikey or ask him again. I don't know if I like the taste of this, give it to Mikey or.
Actually, there's a story behind that. We were at Village Inn here in Titusville one time. I
Uh-huh.
was talking to some friends, and my other friends were all sitting at the table, and they yell out, "Hey, Mikey, come order!" And this waitress stops and yells at the top of her lungs, "Oh well, Mikey, he'll eat anything," and the whole restaurant stops. It's like, oops, not a good time to have the
Mikey,
name
he'll
Mikey.
eat anything.
But that's okay. I enjoy it.
Well, that's yeah. Well, we are going to have a great time with Mikey Haddad here. He has got a resume that tell us a little bit about your career, some of the highlights of what you were involved with in the payloads as
Okay.
engineering.
Sure. I guess get a real quick start on what payloads were. I mean, you got your hazardous payloads.
Well, should we bring that up now?
No, not yet.
Oh,
We'll
okay.
we'll
All
be
right.
in a second. You got kind of your hazardous payloads. Again, that's the stuff that has the solid propellant, liquid propellant, bipropellant, monopropellant, the nasty stuff. That was usually processed in the southern part of Kennedy, kind of isolated to keep it away from people in case there was any problems. Then you had the non-hazardous, which is the kind of the science stuff, and that's kind of what we'll talk about mostly today. And then the follow-on is because there's such a gamut. You had payloads that were satellites, planetaries, observatories, science payloads. So we're going to kind of focus on what was called Spacelab, the Spacelab set of payloads, which was basically a science component of the non-hazardous kind of horizontal processing kind of part of that. And so we'll talk that in general today, but the follow-on ones we'll talk kind of more of a specific part of the Spacelab program, which was at that time it's called Level 4 Experiment Integration. And I'll explain what that is here in a little bit. But I guess starting off, we can go ahead and show what the first slide is. Actually, what is Spacelab?
We wanted to get just a little bit further in there to show us the shuttles of April.
Okay.
We want to highlight on Stay Curious, Mikey, at the beginning of the month and throughout the month, all of the shuttles that were orbited in the month of April. And would you believe 16 of them there in the month? And you go, wow, because you're looking at those and they bring back a lot of memories, I'm sure.
Yes, sir.
What sticks out to you most that you're thinking at
The
there?
Hubble.
The Hubble, of course.
Yeah, Hubble, the Gamma-Ray Observatory, and I got a chart on that.
32 years ago coming up, April 24th,
41
Charlie
C,
Bolden
yeah.
and Lawrence Shriver, the commander, and Charlie Bolden, the pilot, took up the Hubble, and
Yep.
the rest is history. Hawley and Kathy Sullivan and Bruce McCandless were on that mission there, I see. 16 shuttle missions. They have 9 scientific payloads on them, from the Long Duration Exposure Facility, the Gamma-Ray, Atlas II, the important surveillance radar, SRR1, where they actually found things under deserts and stuff, right, that they didn't know was going to be there. You've got a micro lab, MSC1, Space Lab Neuro, very important neurological. The whole mission was spent checking their brains out. Hubble, Space Lab 3, and the Deutsch 2, the German second D2 on there. And you worked on all those in some degree, I guess, right?
See his checkbox sheet.
Yeah.
Yep.
So a very ambitious month, and we're going to take you through some of these missions as we go through the month. Of course, right in the heart of that, Mikey, is STS-1, the beginning of it all.
Yes, sir.
April 12th, 1981.
And that's something.
Was when America's reusable spaceship was launched by 2 of the bravest astronauts ever, John Young and Bob Crippen. Brave because it's the only time we flew a crewed spacecraft. The first time that we didn't do it unmanned. They did Mercury unmanned, Gemini unmanned, several unmanned, and Apollo unmanned, and or uncrewed, as we like to say today. And then these guys rode this without doing they could have done it uncrewed, I'm sure, but they, John Young, the moonwalker, had something to say in that, I believe, that we're just going to do it in there. So we're going to have Mikey back once or twice a month. I told him we'd probably need him back towards the end of the month. Last week of the month, to talk about the Hubble. And one of my favorite patches is the STS-100, because it's the outline of a EVA helmet, a spacewalking helmet, and a lot of meaning in all of these logos of the shuttles. But yes, I'm going to turn it loose here to you, Mikey Haddad, to tell us a little bit about. Take it away, there. Your little program here.
Yeah, well, we're focusing on kind of the Space Lab component of payloads. Again, there's a whole gamut of payloads. We're going to focus on the Space Lab and what is Space Lab. And if you look at the chart here, you see a large cylinder up towards the top left there. That's a Space Lab module. That's basically a pressurized element where you can fly experiments. That was reusable. Components of that were reusable. And then behind that are these U-shaped structures, which are called pallets. That was used for experiments and science equipment that was exposed to the vacuum of space. And so what you see here in the shuttles is kind of a combination of those that you can use for missions. And there was a bunch of different combinations we ended up flying over the course of some 20 years in the Space Lab program. And again, what we would do is we would populate those elements, fly the mission. If it wasn't a reflight, we would basically tear apart everything off of those elements and restock them with the new things for each flight. And you can see the different configurations there. There is a couple ones where it shows a short module. That never really flew. We only flew a long module. But we did fly module pallet comparison kind of configurations as well as multiple pallets.
One thing that comes to mind, Mikey, is the balance factor. You had to have things in the payload for aerodynamic purposes, and it was probably different launching as it was landing, more particularly landing if they're bringing stuff back, right?
Yes, so yeah, a lot of this stuff would stay in the orbiter. All this would fly with the shuttle, stay in the orbiter, and then fly home with it. So what you'll see, a lot of what we did in Space Lab, flew up and came back. This is kind of, you take a module and you cut it in half, and you got a port side and starboard side, and then there are all these different racks, up to about 12 racks that would hold equipment, science, support, subsystem equipment, anyways. And then, of course, down the bottom here, you can see kind of a photograph of what that looked like.
Let's see if I can make it bigger.
Okay.
On the fly here.
And again, those individual racks, we would process each individual rack. We'd populate it, and then we would actually install it on what we call the flight floor. And then all those would then eventually go and meet with the module. And that's where the level 4, level 3, level 2 that we'll talk in a little bit comes in. But that kind of gives you a breakdown of just one of the modules of what it would look like inside if you were to cut one in half.
Okay.
And then the picture down is actually a photograph of what one would look like. So again, this is a pretty complex elaborate piece of hardware that can file a lot of science in a small volume.
Kind of a big deal.
So
there we go.
And then as part of that, there was this other thing, because those pallets were large. There were sometimes we could fly experiments, payloads that didn't need quite that much volume. And Marshall Space Flight Center designed just what was called an MPES, Missing Computer support. I mean, I got it in there. I can't remember what all these acronyms are.
MPES.
MPES, Mission Peculiar Equipment Support Structures. I can never remember all that.
Oh
Anyways,
yeah, that makes
and
sense.
so basically, this would be used to fly smaller elements. This way, you can mount smaller experiments on this and not take up a whole volume of a pallet. So those in combinations. Comment. Yes.
Yeah, Mark Uziak chiming in. They have one of the Space Hub modules at the Udvar-Hazy Museum where Triple T's uniform is on display.
All right, you hear that? Hi, Mark Usiak. He said at the Udvar-Hazy where we've got Triple T's
Okay.
space crew overalls there. They have one of those there.
And one thing I want to point out
Yeah.
on that real quick, kind of on the ends there, you see in the four corners look like bars. Those are actually called trunnions. That's kind of what held the hardware into the shuttle bay, and it had the Spacelab module had those
Like a
the,
slot,
the
it would
plows.
fit in.
Yeah, it would basically a fitting, and then on the bottom was a keel. It actually, so those kind of what held all that into the shuttle. And the reason I'm bringing it up is when we talk, okay, here's kind of a picture of the operations and checkup, and this is where a lot of the Spacelab work would happen, pre-flight and post-flight. What you're doing is you're on the west end of the operations checkup and looking east down this huge bay, and you can kind of read all that, but basically what's in the foreground there is level 4 area. And what that means is the different levels of kind of processing, how we worked. Level 4 is kind of with the starting point. This is where the experiments, the individual experiments from all over the world, and we had experiments from literally all over the world, would come and meet the first time they'd meet each other would be right here in this location. And so our job was basically in level 4, and I was a mechanical engineer there, was assembling this hardware, these experiments into what was called a rack train, which you see kind of on the right there. Those are you see the gray and the brown. Those are kind of the racks that we would populate with the different experiments. And our job as a mechanical was kind of populate those. The electrical software people then would test all that. And so as you go kind of more towards the center of the chart, you'll see what's called level 3-2. What that was where the module and the basic subsystems of the module were.
In the back there, number 9.
Yeah, kind of in the back there, number 9. There's actually 2 there. It's called level 3. What level 3 did was it would prepare the subsystems of the module that these racks would go in. Okay, so you got level 3 preparing the module. We were preparing experiments, okay? Level 2 is kind of where those two came together, was tested, and which is kind of a little farther back in the picture. And then at the very end was called level 1, which was we would test against the actual orbiter flight software. The idea is to find all the problems here. We did not want to have any problems once we went to the shuttle.
From here all the way up to here.
All the way here, yeah. So it's basically like almost like an assembly line
Yeah.
process.
And people were dedicated to each one of those stations.
Yes. Yes.
They didn't walk up and down the line. You actually passed it off to another engineer.
Now, well, actually, what was neat about that, and real quick, is the level 4 aspect of this, which is kind of a unique group, which we were in, was, NASA, most places in NASA, not all places, but most places at NASA, you have a contractor technician, contractor engineering, contractor safety, operations, quality. Level 4, we were a little different. We had only NASA civil servants do that work. The only contractor we had was the technicians. And so we were the engineering. NASA was the ops. NASA was the quality. And NASA was the safety. Very unique. And so a lot of what you see when we talk level 4 was us doing that, was us civil servants doing it. Normally a contractor do. Very, very special, very a lot of fun. The reason I'm bringing it up is initially we would just work in here, but as we went down through level 3, 2, and level 1, eventually out to the pad, we followed that hardware because we'd worked on it for so long. We prepped for that time, and we worked on it when it got there. We would follow all the way through the flow. And so basically what our term was level 4 at the time got changed to experiment integration because we followed it through all these different levels of process. Okay.
Well, this is fascinating. We're talking to Mikey Haddad. He has been an engineer and on the payloads for his career at NASA there. We are indebted to the Marie Louise G West Endowment for buying the equipment to bring you this program. We got a nice endowment last year, Mikey, that bought a great computer and all the things we need to do this Streamlabs situation here. So we appreciate the West Endowment for helping us out here. And of course, you can help us anytime you want. Just get a hold of us, and we're a nonprofit that's willing to take bushel baskets full of $100 bills to help out there. So let's look at it. We're looking at here.
Okay, what this is the very east end of the building. What you're seeing is called a payload canister. It's representation of the shuttle payload bay. And the idea is this hardware never saw the light of day. The room you're seeing that we're in here is actually humidity and temperature controlled. This hardware never saw the light of day. And so what this canister was used for was to transport this hardware, flight hardware, between buildings. Okay, this is it in the horizontal orientation. This is one of the space labs going into the canister, and normally what we do is we go from here. There's actually a transport on the very bottom, which is kind of very flat
And
thing.
you see a person in a blue
Yeah.
bunny suit.
Yeah, we
there.
wore
Give you an
bunny suits
idea.
all the time. Yeah.
Thank you, Jesse.
Yep, great shot. And then the canister itself was sitting on top of the transporter. Then, of course, this hardware would go in. The doors would close. We'd bring that to a certain temperature and humidity. Then we'd take it out the building. For space labs, we would always go to the OPF for these kind of missions.
Orbital processing
Facility. And that's where we kind of got installed in the shuttle. And again, I think the next picture?
Well, is this what they took out to what they call the pigum?
Is what they took out to the pigum? Yes, sir. Yeah, because you can put it in horizontally like this,
and it's vertical,
or you can rotate it to
okay.
vertical. So you rotate the canister to vertical.
All right. So this is the container that they take the probes out to put them in to the shuttle cargo bay.
Yes, sir.
Did it depend on what the components of the payload was, whether or not it was horizontal or vertical?
Yes, exactly right. Yeah, it was a mix. Exactly right, because you could have a mix between horizontal and vertical. You can have just horizontal, you can just have vertical, or both. Yes, ma'am. Absolutely. Okay, here's a picture. This is basically kind of Space Lab 2. This is kind of the opposite. If you kind of look off to the left there, you see the canister door is open. This is pulling Space Lab 2 out of the canister, basically reverse what we did in the operations checkout building.
Mm-hmm.
And the shuttle is off kind of to the right. You really can't see it. So we're pulling Space Lab 2 out and putting it into the shuttle. One quick thing, you see the big egg on the back. That was actually Experiment 6. It came in around Easter time, and so we called it base area. It was it was from the University of Chicago, Cosmic Ray Experiment, and it came in around Easter, so we had a big thing. That was our Easter egg.
Yeah, I was going to guess I'd be catching cosmic rays or gamma rays or something.
And we'll talk more Space Lab 2 later. Okay, now here's this is what you're talking about. This is configuration at the launch pad. This is where the canister now has been rotated.
On the left there, Jessica, there's the canister.
It's got the big red hose coming off of it.
And that's
that's the canister there. And this is after it was rotated to the vertical position. Now, in the old days, we used to have to go out to the vehicle assembly building to do that. Then they built a canister rotation facility that did that for us.
Oh, which is this whole...
Actually, that was another building. This is actually the launch pad. And kind of what's happening here is the canister is being lifted up. That gray structure off to the left is called the rotating service structure. It kind of rotated back and forth. You can see the big hinge there.
And it covers the shuttle.
And it covers the
right
shuttle,
over the payload bay.
Yeah. And so what happened is you're actually seeing the canister getting lifted into the white area there. Is called the payload changeout room. That's basically where the payload would go in initially to the launch pad. Okay, so you take it up to the canister would get up there. You transfer from there into the white room. Again, never see the light of day. You pull the canister down, then this whole structure would rotate and cover up the shuttle. Then from there, you do the installation from that room into the shuttle, and then basically we're ready to go.
It's like a really fancy Pez dispenser.
You can look at it that way. Okay, so that was basically kind of what happens at the pad. I wanted to show you here some of the operations we did in level 4. This is one of the experiments, SCS-7, and we're installing one of what's called mouse. I'm not going to try to pronounce the German version of what that means, but this is basically one of the cans, one of 3 cans going in. And one of our engineers on the bottom there is Frank Valdez with the dark hair. And then our technician, Jay Smith, kind of in the middle there, right here, installing this for flight. And this is basically in the level 4 area. This is interesting because this is the first payload I worked on where we actually flew in space. And if you go down kind of in the very center, on the very bottom, you see it has all the bolts just a little bit right there.
Yeah.
That's one of the primary trunnions. That's what I did for this mission, is I installed those trunnions. And a real quick fact is the technician who worked with Walt Preston, he actually cut his finger because it's trying to get in there and do all those bolts. He cut his finger. Well, he was bleeding pretty good. Well, we couldn't stop the process, and he just ended up taking some super glue, and the thing went right back to work. That's what those guys
First time you've seen anybody do that. Huh?
Modern problems require modern solutions.
Yeah.
We had the best techs on the planet. Those guys were amazing. They taught me a lot of things.
That's cool.
Yeah. And this is another payload that flew. This is one of those payloads that flew on the MPES. It wasn't really a space lab, but we in level 4 were still responsible for. If you go to the person on the very left, that's me.
Okay.
This is the orbiter refueling system that flew on 41G, and that's basically we're doing the installation of it onto this MPES. And back in 1984.
41G, October 84.
84.
Hey, fetch the scroll.
That was Crippen. Oh, that was John McBride's only flight.
And it was Kathy Sullivan's first.
Yes.
That was the first EVA. Yeah.
Can I make you guys feel old?
6th flight of Challenge.
Sure.
I wasn't born yet.
Oh. So basically, that's kind
Doesn't
of.
take much to make me feel old, Jessica. Okay.
Well, what was neat about this payload too, which is really cool, is this one actually contained hydrazine, but at this point it didn't have hydrazine. It had 2 tanks when we went to the launch pad with this, that's when we loaded it with hydrogen. Again, we did that. And a little fact that I'll talk about later, or not later, but in my book, is how one of the persons that worked on the fueling actually set a time of 11 hours in escape suit, which is it's still a record.
Wow, 11 hours, and we have one of those hanging in our shuttle workers gallery that I took you through recently.
Okay, and here's this picture of it on orbit. Basically, you can see this is one of my favorite pictures ever, and you can see the ORS kind of with the flag, and then next to it is large format camera sitting in the back of the orbiter.
Oh, wait a minute. Let's.
Can you get? Yeah.
That's the camera.
That's large format camera there, and there's ORS next to it. That's the one we were just lifting right there.
Is that one of those IMAX ones, or?
This is actually, you're exactly right. This is a frame from the IMAX film Dream Is Alive.
Nice.
It wasn't actually. It was a picture of one of the frames from IMAX.
There's your camera on that.
And the Dream Is Alive we were just talking about, because that was STS-41C with Crippen, and Scobie was the pilot, and Pinky Nelson.
IMAX flew a number of missions.
Get the Solar Max and there. So now we got some
just some real quick
scrapbook
photos.
Stuff here.
Yeah, this is kind of, we also work. Not only we played a little bit, and this is our co-ed softball team. It was interesting for this year. Because we were so busy, we couldn't field the same people throughout the season. Well, there wasn't a many teams, so everybody went to the playoffs. Playoffs were able to field everybody, so we ended up winning the playoffs, going undefeated, and everybody thought we had a bunch of ringers, when in fact, we just couldn't play the same people every week. And so this is basically a picture of us with the trophy from our co-ed team. And the next picture is our mechanical group and some other people. This is a C League champions for the Cars League out of Kennedy Space Center.
Well, I'll use this to comment that Mike Leinbach, who launched a bunch of shuttles through the end of the program, is going to speaking at our 50th anniversary of the shuttle. And Mike wants to talk about the family of the shuttle workers and how you played ball games together.
Yes,
you had barbecues together. Y'all did a lot of things together. Speak to that a little bit about that.
Basically, they were my best friends on the planet. I mean, we worked hard.
What can you say there?
We worked hard, but we played hard.
Yeah, that's it.
And we just, that was the life we had. We lived and breathed the space program 24/7, and they are still, many of them, those people are still my best friends today.
I challenge anybody out there to think, especially if you're 50 years old, think about a couple careers you've had. And I've always fantasized about where would I like to go back and work a full day with a group of people, all right?
Mm-hmm.
And it would be in the newsroom in my hometown of Findlay, where I started, at the Courier newspaper there. I'd give anything just to spend one day of us going back in time and doing our routine there.
Yes, sir.
You understand what I'm saying? And I'm sure you would pick your
softball field.
Well, in fact, the follow on one of the charts, we talk about coming home, bringing the band back together. One thing I wanted to mention too was the time. You talked about the time. When we were working level 4 during the height of that, we were working minimum 12-hour days.
Really?
You would normally work a 16-hour day, and that would go 7 days, 7 days, 7 days. You would not. You would go sometime for a month without a break. That was just what the job took. That all changed after Challenger, but before Challenger, that was the kind of life we had.
So you're talking in 81, 82, 83, up to 86?
Up to 86, we were basically working 12 to 16-hour days.
Well, that sounds like the Apollo era. Yeah. So that's kind of hard on relationships and kids and cats and dogs and everything.
Very true. At that time, most of us were single, so
okay.
We were okay.
Oh, being in our 20s again there. Yeah.
Yeah.
All right, Mikey, let's see what else we got here.
Okay, now this one is a very interesting one. What you see in the foreground here, this is a double pallet train. This is what's called a satellite retrieval mission. There's 2 satellites that failed, their kick motors failed in February, okay?
Quickly on that, they take a geosynchronous satellite that's going up to 26,000 miles or in that area. They would deploy it out of the space shuttle.
Yes, sir.
It would have its own motor called a PAM motor, or payload assist motor, and it would be solid rocket that would boost it when it's away from the shuttle. You would ignite that and take it up there.
Yes, sir.
To clear that out.
Well, they had 2 of them when they deployed on, I guess it was 41B, STS-41B, that did not work. The kick motors did not work. Well, they wanted to go retrieve them. They came to a group here, basically a group here in level 4, and said, well, we want to put together this mission to go retrieve those satellites. This is what it is in the foreground, basically taking 2 of the Spacelab pallets and putting this hardware on it. Again, it was about...
You can see the holes there, Jessica, where the engine exhaust would sit down in it.
And then off to the top left there,
yeah.
Yep, and then off the right in there is the stinger that they use to actually capture up a little higher.
Yeah, up a little higher is the device they use.
Yeah, that's a stinger they use to
actually I see, that little net white thing on the left.
Yeah, that's it right there. But anyway, so they came to us and we said, we can do that. We had a group of engineers in Texas just took that on. And within 9 months, we flew this flight. And we went to retrieve those two. It was amazing work. Those people that worked the satellite retrieval mission.
I believe this is a picture.
And this is a picture of them on orbit. You can see the pallets kind of on the bottom there, the pallet that we worked on. I didn't work on, but I had my cohorts, my friends. And then, of course, them retrieving one of the satellites.
Huh.
Is it down there?
It's actually there, right there's a ring. If you in the center, it's
Yeah,
kind of got
right
kind of a
behind
black
there
area
you
right
went,
there.
yeah.
That's kind of the black ring that you saw. There's two of those.
No, behind that structure, on the
Right
on the base there. There you go. Yeah.
So
And this is so important to point out because this was the dream of the shuttle that they were so arrogant about being able to retrieve satellites and deploy them. They said, forget your single stick rockets, everything's going to use the shuttle. And then 25 flights in, we lost the Challenger crew, and everybody canceled their contracts with NASA, except most of the science payloads, basically.
Yes, sir, yeah.
Correct, right?
Yep.
You're the one that was there. I'm just talking to
Yeah, it changed after Challenger. Yeah, it changed. But this is a good example of how the shuttle could be used to bring things back home that you normally couldn't bring back home. Okay, this is a picture of Astro 1. Like, we actually called it Astro 0. This is in January of 1986. This was supposed to fly in March.
Now, this isn't the Jetsons dog, Astro 1.
No, this isn't Jet, but we did have somebody made a
I've
logo.
seen him as, those who didn't know the cartoon,
Yeah, cartoon
Jetson,
character.
Astro 1 was their dog, and I've seen him used on a patch or two.
Yeah,
I love it.
yeah. This is we actually had a couple of those that because of Astro and that. But this is actually the Astro payload. We were supposed to fly in March of '86. Of course, Challenger happened, and this didn't fly. So we kind of call this Astro 0. But what you see is this is a picture of the team. This is the site stand. This is the same stand that you saw the satellite retrieval mission pallets in. If you look off to the left, that little red circle, that's me in the crowd.
Oh, you're in a circle there.
But,
Circle over the circle, all right.
So yeah, so we basically we stood down enough to Challenger, and then of course this ended up flying 2 more times.
In the middle there, see, I'm salivating because there's 6 telescopes there that they bundled together, and astronaut-astronomer Sam Durrance was a member of that mission, and the second one after that, of course. I don't think Holly was on that, was he? He's an astronomer. Have to look that up. Cool.
And this is actually the Astro 2 STS-67. This is a photograph from on orbit with the basically science package, the telescope package deployed. So
67. That was in
1995.
March '95 there, and your good friend John Grunsfeld was
Yeah,
on that.
yeah, John's a great
With
friend.
Sam Durrance.
Yeah,
We,
Sam's another really good friend of ours again.
We're hoping to get Mr. Grunsfeld on here on a Zoom call with our guest here, Mikey Haddad, senior payload engineer for NASA. He knows his stuff, and we're going to try to give you Stay Curious programs that relate to how all of this going on in the 90s was so important to what's happening on the space station in 2020, right?
Okay. Yep. Yes, sir. Yeah, it was kind of a prelude to that. One thing to note is what we did at level 4 and a lot of work was we would do basically dry runs of what the crew saw on orbit. This is the flight harbor. This is how I'm going to operate on orbit. So the crew would come down for a lot of this testing. Basic bottom line is the astronauts became good friends of ours because we spent a lot of time with them getting the hardware ready for them that they're going to use in orbit.
Well, they want to become familiar with it.
Yes,
They
sir.
want to know how to use it, and you're the expert. So,
Yes, sir.
yeah, it's a very interesting job that you've had to deal with management and then the people that are going to space.
What this is basically after we start reflying. This is our mid-deck team. Again, payloads can be in the mid-deck as well, and we had also what's called side-mounted carriers.
Please tell us where the mid-deck is for those.
The mid-deck is the very front part of the shuttle. What it is the very front part where the astronauts basically live in the shuttle. The flight deck is the top part. That's kind of where they fly, the crew flies the shuttle from. It's got the windows and that. And then underneath that is actually, I think it was like a basement, is the mid-deck area. And that's where they would eat, sleep, and that's where a lot of these experiments would be housed as well. What this is a picture from STS-29. This is a group of us, and that's me in the red sweater, getting ready to basically put the mid-decks in to support the STS-29 launch. This is the launch pad. And if you kind of look to the back, now it's looking at the back, there is basically the crew access arm. Okay, yeah.
Oh, okay.
Yeah, and that's how we would, of course, get
The white room back
white
there,
room.
yeah.
This is a Hubble. Basically, it's me on the bottom. It's kneeling down with the eye hood. This is basically getting Hubble ready for its mission. We were at the launch pad. This is basically the battery ops getting Hubble ready to launch. So that was a
April 1990.
another one of my favorite pictures. And
Yeah, I'd say finally getting the Hubble
Yeah.
launched up there.
this is the Gamma-Ray Observatory, which is named later Compton Gamma-Ray. And this was, again, this is one of those hazardous payloads that flew. It's an observatory payload. And I worked on, my part of this was supporting the hydrazine load, which is about 4,300 pounds of hydrazine, which is basically the propellant to control it on orbit. And again, that little red circle is kind of what I look like.
Very
back there.
heavy payload, the Gamma
Yes.
Ray,
Mhm.
and it was launched in 1991 on April 4th, April 5th actually, and it had a female pilot. Linda Godwin she wasn't a pilot. I was thinking of 83 had Susan Still on it, but yeah, STS-37 with that was
Jerry Ross was on that one?
OV-104.
Mhm.
That was Atlantis.
Mm-hmm.
Yeah.
Yeah.
Yeah,
So
Jerry Ross is on 3 missions in April of his 7.
Okay. This is kind of, remember the movie Armageddon?
Yes.
And the armadillo that they use. Well, this is out in the parking lot
It's real life.
of the operations and checkout building when they did the filming. Part of the filming was done in the operations and checkout building, kind of what we were looking at. And I just had this picture of me next to
Oh,
me.
really?
I thought it was just a model. This is actually, I guess, a Humvee modified, because this thing's running around the parking lot and all of a sudden that hatch pops up and somebody jumps out of it. So this thing really worked.
Huh.
I mean, this is a real vehicle. It's amazing. So this is actually what this is. This is a close-up of an interface between the Node 1, which is a kind of a core component of the space station, and the airlock. And what you're seeing here is basically the components that run across those two interfaces. One of our jobs we had was making sure these interfaces worked. First of all, does everything reach? You can see the crisscross. There's a little problem in the
Now,
design.
how big are we looking at? Is this like looking under the hood of a car,
You're
that
looking
big
about,
area? Or?
about 6 or 7 inches.
Oh, okay.
is what it is
Oh,
about
so
wide.
those are only 3-inch pipes or diameter or something like that.
Yeah, and so
Okay.
they're the gas, fluid pipes, electrical pipes. Basically, this is the interface between the elements. So when
Wow.
the node is up on orbit, and then the airlock would bring in, they would be mated with a common berthing mechanism based on the mechanical, and then these interfaces were connected between the two. We tested that on the ground to make sure this would work. Because some of these flew years apart. And so we'd have to create simulators, and this is basically a close-up of one of those interfaces.
Kind of an innocuous looking photograph, Mikey, but that's life or death right there.
That's
correct,
basically-
right?
Yep, gives the airlock life, basically.
Uh-huh.
Yep. And this is basically between the node and the lab. And you can see this is pretty populated, all these cables, and our job was to make sure these cables would fit and everything would go together. So that was another part of the job we had there. What it is, this is kind of the work that we did in level 4 that then we transferred to space station, because we had that kind of flight hardware experience. Okay.
Hopefully everything's labeled properly there.
Mhm.
You got good blueprints
Yeah.
for that stuff, right?
Yes. Oh,
Let me
yeah.
ask you, what do you work off? Did you work off a physical checklist, notebooks, blueprints?
Drawings. We did
Drawings?
drawings, interface control, what we call interface control documents, ICDs. That would kind of tell us what's supposed to go where. And then our job was to make sure that what the actual flight hardware did what the drawing said it was going to do. And a lot of times it didn't work. So our job was fixing those problems. We didn't want to have those problems in space. We wanted to find them on the ground.
Now, one thing looking at Mikey's resume that I talked to him on the phone about that we're going to have a complete show about is you are an expert on habitats. You've had the training and acquired the knowledge about what it's going to take to live on the moon and Mars, right?
Yes, so yeah, what we did is I was part of a group that would work with lunar surface systems for the Constellation program. Again, how you live on-
Constellation program,
which was
20 years ago, another administration wanted to go
Yeah.
back to the moon, and basically Artemis is the same thing
Yeah.
the Constellation program was.
And so our idea is basically how do we get elements on the surface of the moon to create a moon base. And so we were brought in to help try to make that happen. And what this is actually, it's called Desert Rats. And again, I'm so bad with acronyms, so I'm going to go ahead and get this out. It's a Desert Research and Technology Study. This is actually out a place called Black Point Lava Flow, north of Flagstaff, Arizona. This is where they're simulating what would be like to be on the surface of, like, say, Mars or the moon. And this is a habitat. Basically, the bottom habitat is something that was designed, built into the JSC. The top part was actually from one of the universities that wanted competition. I think it was the University of Wisconsin. That was kind of living quarters, airlock off to the right. And basically what we did, we went out there. I went up there for 10 days and supported these operations, basically trying to create what would be normally a moon or Mars base and how to do that. So that's what this is. Kind of one of those last things I did as an engineer. Shortly after that, I retired. This is in August of 2011.
Well,
So-
that's a 10-year-old. Do you keep up with what's happening out there? How's it going? What is this a viable habitat?
Good question. I think the Desert Rats program isn't in work right now, but I mean, the idea of doing this is still out there. Yes, oh yeah, because now we're talking about going back to the moon.
Yeah.
And then on to Mars. So this activity was kind of a precursor to what we're doing today.
That could be one of the early lunar modules that they would live in.
Kind of a mock-up to see if it would
Uh-huh.
work. Yes, sir.
Okay.
Yeah. Okay, what this is a picture of the Space Station Processing Facility under Kennedy Space Center. What we're doing here,
SSPF.
yeah, the SSPF is we're actually, a lot of this equipment that flew on space stations was launched sometimes years apart. Well, how are you going to make sure that that stuff works when it sees each other in orbit? And that's what we're doing here. It's called multi-element integrated testing that we push for. There's a lot of people outside of Kennedy, not say everybody, but a lot of people outside of Kennedy thought we didn't need to do this. We thought we did. We ended up getting it. Finally, there's changes in the schedule. Bottom line, this is a lot of the elements that we hook together to test on the ground before they would see each other in space.
And these trusses are so important. Each one represents an individual shuttle mission
Yes.
that carried them up there. This is the backbone of the solar panels and the modules that are hooked up to it. So,
Yes.
from S1 to S4 was probably a good 6 years or more difference in building it, from 99 to being complete right in the 2009 era. Yeah, right.
And so this is kind of this is one of the tests that we were.
Yeah, I didn't think about that. I'm kind of amazed that it was all built already.
It was there was parts of it, yeah, that we had.
Though in it, that they didn't say, okay, we got Trust 1 done, we'll ship it. Now let's Trust 2's almost done.
Well, some of it was in kind of maybe not the final flight configuration,
right.
and they would.
But it's impressive you
close,
got so much of it together.
Yes,
there.
sir. Okay, what this is?
What are we talking?
This is post.
This
is
isn't
post-retirement.
NASA.
This is retirement stuff.
Warning, not
Interesting
NASA.
seat.
Okay.
This is actually what's called. This is a place called in Kingsland, Georgia. It's just north of the border off of 95.
Let's go.
Called Kingsland. It's called Neutral Zone Studios.
I'm in.
And what they did is they recreated all the sets from the original Star Trek series.
Did they?
And I had a good friend, Mike Wright, who's up at Goddard Space Flight Center, told me about this place. And you go in there, and
It's called again what, Mikey?
called
I
the
know
Neut-
you got some interest. People going.
It's called the Neutral Zone Studios.
Neutral Zone Studios.
In
She's writing it down.
Kingsland, Arizona. Okay, now it's used for fan films basically, but they recreated the sets
Is
to
this
scale.
when they did that fan film with Vic Rignonia in it?
Yes,
Yeah.
it's Star Trek Continues
Yeah,
was filmed here.
That was real good.
And
That
on
was a
these
real
sets.
good one.
Yeah, it's an amazing place. So you're walking back into time. This was Nichelle Nichols. She came to do a special. It's called, let me make sure I get this right.
And that's you, right?
And that's me, Breaking Barriers. Yeah, what it
Okay.
is she came in here and she basically did told about her life as an actress. She's an amazing woman.
Yeah.
Amazing woman. You can see I'm just in a tank top. This is in May. This is
Yeah, we see that.
It was
Mikey.
brutally hot in
You're
there
just in a tank top.
It was
yeah.
brutally hot in there. There was no air conditioning. She's
Oh,
in
I'm
her
gonna
full
see
dark,
Nicole. I think I'll just wear my tank top.
And she sat there and
Doesn't see
it
my
was
bulky
amazing.
muscles.
What was amazing? No, it was just because it was so hot. That's what it
She's
was.
in the captain's chair.
She's in the captain's chair. And in the show or the documentary, she talks about how she gets to the captain's chair. But she's an amazing woman. I ran the teleprompter, for this when she was doing this series, this special, and she did not see that script until it appeared on the
She
teleprompter.
dropped it.
No, she would
Really?
just bang like that. As the next sentence was coming out, she can see that it required some emotion, and she would change her emotion to read that line. Never seen it before.
Well,
in her
that's
life.
some acting. for sure.
Amazing woman. She wasn't. So it's
Yeah,
just a
she has
picture.
been a good representative of NASA and
Women in Space.
Women in Space.
Women in
Yeah.
Space,
Again,
yeah.
Breaking Barriers, and this again was filmed at the Neutral Zone Studios in
I'm
Kingsland.
gonna have to
Sweet.
pull that one.
Yeah.
Do we know if it's on
All right.
which platform? I might have to drop a
It's
link.
it's on Facebook.
Okay.
Yeah.
I'll have to see if I can drop a link, y'all.
Okay.
Okay, back to some real space.
Okay.
Okay.
listen.
What this is interesting. What is one of the projects we're working on right now is called the Astro Restoration Project. The picture earlier, which showed Astro that was going to flew on STS-35 and STS-67. After the missions, sometimes that stuff goes to the museum, sometimes it goes to the junk dealer. Some of Astro basically was retrieved from basically junk dealers.
Wow.
And this is one of the components called the cruciform that we retrieved. And we're actually in the process of restoring this. It's called the Astro Restoration Project. And right now it's being done in Huntsville. It's working with the Smithsonian National Air and Space Museum in D.C. And initially this was supposed to be done there, but they were busy doing renovations. And so we ended up getting.
Do you guys want me to maybe manipulate that? Zoom in a little bit?
This is off the Facebook page for that, right?
Yeah, this is
That
basically,
Mikey?
this is the
Yeah, you can
Facebook, the
zoom in.
website. Yeah, if you could zoom in on that for the Astro restoration projects. Now, I don't want to name names, not too many names, because I'm going to forget somebody. But the core people, the project lead for this is Scott Bongen, who was a level 4 electrical engineer, who basically retrieved and saved some of this stuff from basically being melted down. He saved it. We got storage units. We put in people's hangars, people's garages to save it over the course. And we can go and talk about this a little bit when you go to the site. But it was basically retrieved, and the idea was, okay, Smithsonian says we want to create something at the Smithsonian in D.C. What could you do for us? And we said, we've got pieces of Astro that we saved, Scotty saved. And so Scott was a project lead on this right now. Another person very valuable is Maynette Smith, who basically created these websites. She's an electrical engineer from level 4. She created the website. She's been our outreach person. She's done amazing stuff. And then the other person, core member of our team, was Byron Bonds, who was a gentleman who works at Teledyne Brown and Engineering up in Marshall. We actually worked with back in the 80s and 90s, and he's still working at Teledyne Brown up in Marshall, and he was a major player in getting this equipment and a place for us to be able to do this work. So basically, Scotty, Maynette, Byron, and myself are kind of the core team, and I know we're not the only ones. There's so many more people that have contributed to this project, but this is ongoing right now. This is happening as we speak.
Well, that is fascinating to save. Do they have the optical instruments?
Well, in fact, I think this is the next photograph.
Yeah.
Okay, this is when we were tearing the cruciform down. We actually had to strip it down. When we start taking these blanket materials off, and you can see some of the cabling kind of bent there, we found rat's nests. We found dirt daubers, a bird's nest. Basically, it was a mess. We had to clean the structure. That was part of what we did at Marshall Space Flight Center. And this is showing the cruciform kind of with the blankets and cleaning up that structure. And again, there's a lot of people. I used only my picture because, again, I didn't want to leave anybody out. So instead of leaving somebody out, I just used only me. But there's a lot of people that have worked on this.
And that's what you're talking about saving right there.
This is this is basically the telescope packages that we saved. This is actually an article we wrote for the magazine over in the UK. The co-author of my book is in the UK, and he was basically an editor of this magazine. He says, I think this story about the Astro Restoration Project would make a great article for our magazine, and that's what this magazine is. It has the article about how all this came about, how we saved the hardware, how it all come back together. And again, this is like we're putting the band back together. All those people, the people that we worked with in the 80s and 90s to fly this, we're now doing that to bring it back for museum.
Well, we want to stay on top of that. Did you hear that? Robert Law, he's in Dundee, Scotland, enjoying his afternoon, evening cocktail. He's familiar with Space Chronicle, I'm sure.
Yeah.
Probably read this in there.
That's an article that we wrote.
I did want to mention this. This picture reminds me of that many of you space geeks would be amazed at the lack of reverence, shall I say, that NASA does not have for some of these relics of the space age. There's a street called Ransom Road on the property out there, and they just throw stuff out there. They don't cover it up. I know for a fact that the Lunar Orbiter module and Ranger models that were at the Kennedy Visitors Complex Saturn V building, they took them off the top of the wall there when they reconfigured that a couple years ago and just threw them out there in the rain and stuff like that. And it bothers me because some of that stuff is too big for our humble museum, but it should be preserved somewhere. And here you are trying to preserve an instrument of science that cost millions of dollars.
Yeah, back then it was millions of dollars.
And then they want to melt it down and break it down afterwards instead of bequesting an observatory somewhere. Would you like to own this? We'll give you this telescope that was in space. And
well, there is a process that was set up to try to do that. So it wasn't thrown into the weeds. So you're right though, but a lot of that happened, and the components of Astro fell under that. Now, one thing too is kind of how did we get this? I'll just real quick story was Scott again led the effort. He would go to Ransom Road or go to the auctions where the stuff was being basically auctioned off to junk dealers, and he would bet on it with his own basically personal money to save it. After a while, the junk dealers realized when they see Scott show up, hey, this is some valuable space stuff. So we had to create what's called a mole, where we had people that the mole we'd have.
Can I be the mole?
We said people that were basically part of level 4 would go and bid on this stuff for Scott. so that people didn't know who it was Scott.
Yeah.
It was just part of the story.
Well, I'm making a personal comment there, but it's not right because this is government money. This is our taxpayer money,
Yeah.
and we should have a say in when they're done with these things. Maybe we could give them just to some nonprofits and other people that would inspire the next generation by looking at him or using them there.
And this is a photograph of what it kind of looks like today. We refurbished the cruciform itself, and then the instrument off to the right is called the Wisconsin Ultraviolet Photopolarimeter Experiment, WHOOPI for short. And it was one of the 3 telescopes for the Astro mission. The other component you kind of see on the right there with the 3 baffles, that's what's called the optical sensor package. Think of that as that.
Can you enlarge that, Jessica? I can't do it without covering him up.
Equal.
Yeah.
Oh, there we go. Oh,
Okay.
equal. Thank you.
Yeah.
Okay.
And that's kind of what kind of helps point these telescopes in the right orientation. This is a photograph from the atrium at the U.S. Space and Rocket Center at Marshall Space Flight Center, their visitors museum. And kind of what happens is we're doing a lot of the integration. We'll be doing the integration of the rest of the components over the next couple of years.
Awesome. I
Okay.
can't wait to see it my next visit there.
And then eventually the idea is to ship this to the Smithsonian National Air and Space Museum in D.C. That's the goal. And so what we've been trying to do is recreate the Astro payload that flew in space in the 1990s. Yeah. So big team of people. One thing we found is there's components that we found and we're able to retrieve. There's other parts that are lost. We have no idea where they are. In fact, we had groups of people, organizations there at Marshall that helped us build components, piece parts that we didn't have. This is one of the major elements. We don't know where it is. We don't know what happened.
Go to your junkyard
And the reason
you
I'm saying-
see the
yeah.
integrated
exactly right.
radiator system
That's
at
why
your
exactly I'm bringing it
junkyard.
up here was
In search of.
in search of.
Yeah.
I want to put it out to the planet so everybody's watching. If you know where this component is, rectangular object, we're thinking it's probably sitting as a flower pot in somebody's backyard right
I
now.
bet.
But
It's
we
probably-
would
it's
love to
probably
find
not
that. Okay, so we would really love to find that. So anybody watching knows where this flight IRS is, please let us know.
Yeah, well, we've got the hatch of the first the first Mercury Atlas launched that blew up, and we have the hatch in our Mercury gallery there that was found at a junkyard. Well, we've been enjoying a great conversation here with Mikey Haddad. He is going to join our Stay Curious family and give us at least once a month the shuttle payloads of the month. Here is your book that you have.
Yeah.
And we will have this book in our museum here soon, but I know that some of our Stay Curious watchers are going to want to order this. So is it on Amazon? And they can order it with Amazon Smile. And we are, of course, your favorite charity on Amazon Smile.
Yes,
It's
you
on
can-
Amazon?
You can get it off Amazon. You could also get it off the Springer Publishing website.
Direct.
And there's other, and there's also, I think, Barnes and Nobles, but
All of them.
And there's
Amazon
David Sawyer, you were saying, is in Europe.
he's a co-author. Basically, he's a professional author. I'm not an author. I'm an engineer,
Mm-hmm.
and trying to write this book, and it's a long story, but basically, it came down to where I ended up,
I gotta put the words and make them sound good.
and and his brother, who's Mike Shaler, was the editor. Those two gentlemen made this book possible.
I know
It
it.
took my third grade grammar and
Third
they
grade
made
grammar.
they made it readable.
That's all you had to complete was the third grade to get in
Only-
NASA? Gee.
But yeah, but he's a seasoned author. He was actually again the editor for that magazine, and so he's a co-author for this book. And
Is this kind of technical, or is it layman's terms? Or
I tried to write it to where anybody who's interested in the space program could read it. It's not a
Good.
book of calculus formulas.
we forgot to. Oh, there it is, right there.
Yeah, it's right
Yeah.
here.
Yeah.
And basically, you can see it's about 520 pages, and
Good read.
and it tells a story. Again, you got the Spacelab program that had a lot of components of it. This tells the small piece, the level 4 piece, as a major piece, but a small piece of the overall Spacelab program. So it focused in on the work that we in level 4 did for Spacelab. There's and again, it was more from an engineering standpoint. You had operations, you had quality, you had safety, you had all those NASA people that worked in level 4. This, because it is so huge, this focuses on just the engineering and tech aspect of the work we did. Yeah.
Well,
So-
fantastic. I can't wait to read it and check it out there. Spacelab, the payloads, and the people.
Yeah. What this is kind of a follow-on to the book. trying to put 20 years of Space Lab history into a 500-page book, you just there's a lot that couldn't get in there. And so what we're doing, that's where you're really helping us out, is the book was the tip of the iceberg on what we did in level 4, how all that hardware was assembled, tested, and basically made operational for flight. The book was just a tip of the iceberg. What we're doing here is we're trying to create a process to tell more of that story, and that's where Stay Curious is going to come in. Very, very helpful. We hope to bring members of level 4 here to tell more of that iceberg story that is not in the book.
Well, no, Mikey, you're helpful to us because our nonprofit, we love our space workers. We consider them national treasures.
Thank you.
Because you did things that don't relate in any other part of our society. There's no other Astro labs over there at any other businesses around here that went to space and so forth. So we're very grateful. And I think Jonathan Ward's a friend of yours. Jonathan wished you well on our Facebook post about you, and he's a good friend of our museum with his books that he's done.
In fact, Jonathan was the one. I actually went to Jonathan to try to help write this book. He says, Mike, it's a great idea, but I'm busy. Let me give you somebody who's a Space Lab nut that wants to write this book with you, and it was David.
Oh, cool.
So he was the one that got me in touch with David, and it was the connections, and after that, it's just history. I mean, it was the perfect match.
Well, Jonathan Ward, the author of Bringing Home Columbia with Mike Leinbach, but also his latest book about astronaut Eileen Collins, Breaking the Glass Ceiling, with our first pilot and Commander Eileen Collins, who I've met many times, and if you've ever met her, you'll know you've met a classy first-class lady for sure.
Absolutely.
We got a few comments and questions there from Trekkie Techie, who's behind our Streamlabs engineering today. Marty took the day off, but I'm sure he's watching.
Yeah, I'm sure. I don't know. He hasn't liked it. But Carlton says that he got to photograph one of the Space Lab modules before it flew over at the building near Cape, and they let him sign his name where all the workers did before the flight.
Well, Carlton Bailey putting his name in space there. Did you do that?
Yes, sir. Yeah, we had things that we would sign and before the missions that we worked on.
It's like Kilroy was here all over these things, isn't it? Yeah. I mean, I know you guys. You're not going to let something go to space and not take something personal with you up
yes,
there.
Sir. Yes, sir. Yep, that was part. It was a lot of fun. Real fun.
A
lot of work, but a lot of fun.
Okay, question from Mark Uziak. If they would have activated the Vandenberg pad in California, would you have gone out there, or would they have had a separate California team?
That's a real good question. In fact, yes, I was a member of the team that went to Vandenberg initially. To how would we process a space lab and level 4 in that through Vandenberg?
Really?
So I was a member of the team, the payload team. There's a lot of people that were involved, but I was a member of the payload team that would fly out there. We flew out on NASA 4, which at that time was a prop plane, turboprop. Took a long time, but yes. We were planning on flying out of Vandenberg, and so I was a member of the payload team on how all the facilities and the work we would do out there in Vandenberg to fly the missions, and of course that never happened. But yes. That was
out there on the launch pad they call Slick 6, where Triple T was born, and Jessica and her husband Troy spent some of their time out there. Yeah. Vandenberg. That was going to be America's. They were actually going to buy the Orbiter 103 Discovery. And Air Force was, and then fly military payloads and obviously some science polar stuff out there.
Yeah. One of the kind of trivia facts too about Slick 6 was, for shuttles, the launch control center is miles away from the launch pad. Right?
Yeah.
The launch control center for Vandenberg is 1,200 feet.
Yeah.
From the base of the orbiter, so we were going to draw straws.
It was pretty tight. It was pretty tight there. In fact, I was talking to Mr. Jay Honeycutt about the tunnel that was taking the 3 engines of the shuttle's exhaust out this tunnel.
Yes, sir.
And they were worried about having some hydrogen in there that hadn't burned that might explode. Yes, and I said, well, you're going to have some big fans, right, to blow that through. And Jay Honeycutt said, Mark, we were going to put a jet engine in there to blow.
I was wondering how they were going to solve that problem.
Yeah, they're going to put a jet engine in there to blow it through there. And that was interesting. But a chapter of NASA that never happened, creating a shuttle pad at Vandenberg Air Force Base, which is very important to our nation's security. Many spy satellites launched from there.
Yes, sir.
On there. So, Mikey, we've really enjoyed breaking the ice with you here on Stay Curious. Is there something you'd like to share with our our watchers today on Facebook, YouTube, Twitch, and Spotify that we haven't talked about?
Just looking forward to coming back with other members of our team to work those Space Lab missions to tell more of the story.
Yeah, we intend to have Mikey here and somebody else, and I'll get off the set here so we could have do a Google Meets with them or Zoom, whatever they prefer. And we hope to get John Grunsfield, astronaut, on here. I've told you that's at the top of my list. All right, and there we'd love to talk to him. And well, thank you very much.
It's
been
a pleasure, Mark.
great.
Thank
well,
you very much.
Pleasures are all
for-
ours, because without great people like you helping everyone else out there stay curious, this show would have tanked a long time ago. But we're proud of what we're doing, and doubly proud to present a forum for our space workers of America, which I consider the greatest chapter of our American history, one that has revolutionized not just our country but the entire world with payloads that people like Mikey Haddad have had things to do with. So thank you very much.
It was a pleasure, Mark.
On
Thank
behalf of our whole museum here, and Jessica Galloway, thank you for coming in and doing your Trekkie Techie stuff there. Please enjoy your trip to Chicago. I'll be looking at all your tweets and Facebook and stuff like that, making sure.
It'll be popping off.
All right. Well, we're so glad that you're all with us. Tomorrow's Friday. You know what that is, Tales from the White Room with Triple T. So I'll be back with Travis Thompson. I'm Mark Marquette, and we'll see you again tomorrow to bridge the space between us.